100,000 scientists across all fields worldwide. His Google Scholar citation is over 238,000 with an H index of 240. Now let's welcome Professor Wang to give us the lecture about the triple electric nanogenerators for self-power systems and large-scale blue energy.
Thank you for the introduction. Let me get this minimized size. And I'd like to thank the invitation from Micro Nano Letters, and this journal is grow very great and reach impact factor almost 10. So it's make a great contribution to the society and community. So I'd like to use this next 30 minutes to give you a brief talk on our triple electric nanogenerator for self-power system and large-scale blue energy. And when you talk about energy, there's a lot of need. I also serve as the chief editor of Nano Energy, this journal. And as we march, the society march from the ancient time to today, the energy need changed too. We still rely on the traditional energy based on coal and oil. Each change in the energy revolutionized our society. So as we enter the 21st century, there's a lot of new challenges and new opportunities. So what are the new opportunity, new challenge related to energy? Our traditional way to deliver power is through the central power plant, through the cables to factory, to schools, to home, to the city. And we also have the storage units, which storage the energy for portable electronics, for mobile electronics. So these are the major two approaches for power delivery. But once we enter to the, furthermore, the people's demands, the society's needs are increased dramatically, especially in the area of handheld electronics-based devices. This large increase, so-called big data. You know, we have a data. Where the data come from is from those devices. With smaller size, huge numbers, mobile and wireless. So how do we meet the energy of those devices is what we are looking at. So if you look at this energy delivery here, is basically we look at it from the traditional power plant to your home. So this is a cable power delivery from concentrated energy to fixed sites, ordered delivery. But as we into the Internet of Things, mobile phone-based electronics, there's a lot of distributed energy. So from concentrated energy to distributed energy, from ordered application to some sort of disorder, from wired to wireless. So this huge numbers increase every day. So therefore, you can view this one as analogy to the entropy in chemical physics. And the entropy for energy distribution is very different from what we used to do. So how do we meet this daily increased demands, society and whole global? So we introduced this solar-powered system 2006, 15 years ago, I introduced solar-powered system. Can we make this device not only sense the environment signal, but also process and send a signal wirelessly to wherever it should reach? And this device can be self-charging without an external power source. That's called solar power system. And that's today become very much popularly utilized in many fields. Okay, so today I just present one of our major inventions made in 2011, and it's called triple electric nanogenerator, called TENG. This is one of the mode of TENG called contact separation mode. Two dielectric materials contact separation and the surface being charged. Then if the distance between the two dielectric be increased, the electron flow from one electrode to the other. So this is the way we have been talking about the energy generation, right? Energy generation here. So we knew this one, but what is the fundamental? What's the application and what are the challenges? So let's look at it. If you want to see the advantage of the traditional power generator with the new generator, what's the advantage? What's the key difference? Okay, it's not only just a choice of materials. It's way much beyond that, go to physics level. So this is the metal rod called electromagnetic flux, and this is the contact electrification between two dielectrics that give you the power generation. Let's see the difference. Let me just show you the difference. Okay, see? This runs at a very fast pace. This runs at a very slow pace. Okay. Let me introduce to you. So this why this have to run at a fast pace, because the power output is low. If you run a slow pace, it cannot drive it. But this one is slow pace, but the power is enough for those lights. The key difference is this. See, this is the frequency dependence. At low frequency, the TNG output is a lot higher than the electromagnetic generator. So what is this low frequency? Is the frequency in our daily life. So TNG is a very powerful technology for harvesting irregular, low frequency, distributed energy at a high efficiency. Okay, so now come to the basic. When you talk about these things, what's the basic science? If you talk about trouble electricity, everybody knows it, but not everyone even understand the fundamentals of trouble electricity. For example, in the textbook you write metal is a plastic rod rub on the fur, you get the electrostatic charge. The question is why? Why this negative charge? Why these other positive charge? So this is the fundamental ones. So we have studied this for the last few years, and we propose some models. Let me just review one model for this. Because the trouble electricity occurs for any materials, any phase, solid, liquid, gas phases. So it needs a generic model. So we propose this two atomic wave function overlap model or electron cloud overlap model. So this is one atom, this is the other atom. If the separation between two is slightly larger, so there's no overlap with the electron cloud. Now, if you bring the two together, the barrier, you see, the barrier used to separate the transfer electron from here to here is lowered. So electron can transfer from one side to the other one. If you do an animation, it's look at that like this. This is the bonding atom, electrons here, this bonding atom here. Then you bring together, and then new potential become lower the barrier, the electron transfer can occur. So this electron transfer occurs, this is the trouble electricity. You can use this model to explain for solids, liquid, gas, or liquid and gas. Okay, so in this such a case, electron remains on one atom, and the other one will have positive charge, the other one negative charge. And this is the case we have observed from many materials. So this kind of transition we have studied a lot in this regard. So just briefly tell you, because of time limitation. So used to believe, so what is tribal electricity? Is a type of contact electrification in which certain material become electrically charged when they are physically contact. This definition is partially right, is partially wrong. The partial right is that it just give you two material contact give you, but did not explain why. So the definition is contact electrification is a quantum mechanical electron transfer process that occurs for any materials in any states, liquid, solid, or gas, in any application environment, and a wide range of application range temperature. We found up to 400 degrees C it still exists. So we complicate the situation of trouble electricity and contact electrification. This is a scientific term. This is an engineering term. We just use tribology convoluted with the scientific term become engineering operation. So therefore, we used to do not understand this very well is because we complicate the process. Okay, so this is what is happening. The second one, if you have this electrostatic charge, how come it make electron flow? Used to be you have a metal rod called magnetic flux. The Lorentz force drive electron to flow, you see conduction current. But in our case, it's different. This goes to Maxwell's equation. Much different from this. Maxwell's equation was proposed for electromagnetic wave, but we expanded Maxwell equation for energy. So how? If you look at this displacement current term, this Maxwell introduced in 1861. This is the standard term. This is the time variation of magnetic field, electric field give you the current. It's not a direct flow of current. So this one, if you see, in our case, this medium polarization term missed one term. What term? If you have a surface charge due to trouble electricity, you have a natural contribution to this polarization here, even there's no presence with electric field. So we added one term in the Maxwell equation. Say here.
Dear audience, we are experiencing some technical problems at this moment. So I guess there's something wrong with the internet connection from Professor Zhongling Wang's side. So we are dealing with this. Please keep your patience. Thank you.
Help. Derivative here. So why do we still call nano generator, which was first introduced, use nanowires for power generation, but now is displacement current driven power generator technology. And for piezoelectric case, for tribology case, it's all inclusive. So we call nano generator, which stands out of the traditional power generator technology. So nano generator is a field that uses displacement current as the driving force for effective converter mechanical energy into electric power. Even use nanomaterial or you don't use nanomaterial, it doesn't matter. So therefore, it's a physics change as we are speaking. So what fundamental contribution? The fundamental contribution is this: is modified displacement current. Originally, Maxwell used this to predict the electromagnetic wave, and it contributed hugely to today's society. But now, if you add an additional term, is the power generation of nano generator here, which is the energy and the sensors. And we use this one, expand Maxwell equation here. So basically, this term is low frequency. This term is high frequency. Two are normally do not couple, but now if you couple them together, you can have a lot of new things to happen in the future. But today we just totally talk about this term. So this gives you the basic theory of this theoretical framework. So I just, to be brief, okay? So now, when you talk about the TNG, what are the applications here? Let me give you some introduction here. The first one is use human activity for power generation. Okay, if you put in a shoe insole here, use a little tubular structure here, you can get a lot of power out of this. At least it's enough for some small electronics here. So you can use conventional materials as a power converter, use human motion here. You can also make solar-powered electronic papers. The paper can be electronic power. You can see this one. Let me show you. You can use this one to drive change the color of the paper as your physical motion here. So you can imagine you can future have a T-shirt, and the T-shirt can change color when you are jogging. See, the color changed here. Let's swap one more time, and then you can get another one. Okay, become red. The other one, I can make this color switches. You see, just once the color switch from one side to the other side here, you can make an automatic color change, and also with the green and the other colors too. See, okay. Just physical motion made it change. Okay, let me just show you the slide here. Okay, and then you can also have other devices as well. Self-drive electronic paper-based device here. Okay, let me see this one. Yeah, so you can make all kind of good things from this things here. You can use the material choice can be very diverse. Use a silicon. You can have multiple twist ones here. It's become a little power generator and a sensor. You put it on a person's arm. You tap in any specific point. You have a signal being received here. This is for sensors. You can also put on the floor. Some people's free walking. You can have a power generation here. Okay, so this is all needed, not only for power generation, but for picking sensors. Medical purposes. You can use heartbeating of small rat to drive a pacemaker. And recently we made this one to be used. This one to drive a large, the basic human pacemaker. And we make use large animals. This is a big pig, 50-kilogram pig for the experiment. We found that the breathing of this pig, the motion that drive this TNG can drive the pacemaker. So this for the first time it changes a lot. And this one can also send signals. You not only can detect the power of the pacemaker, but also can detect the signals in vivo. And inside the body, we have reached almost half microjoule our power output, but the minimum energy drive of pacemaker is 0.37. So we already go through beyond the threshold. So this is a very exciting news, and our effort for 12 years, finally we reached the possibility for self-powered pacemaker. And this drug delivery with use TNG, without use TNG, put on skin, you can infiltrate the drug into deep tissues here. You see, the efficiency enhanced by a factor of 5 if you use our TNG. Just physical motion change the effect delivery of drugs by a factor of 5. Fabric, a lot of people do fabric studies here. How can you make a fabric smart? Trouble electricity is the very basic effect. You can make this one into different design here, and you can also make this one into a power generator. You can also make this one into sensors here. So our group was the first to demonstrate fabric-based, fiber-based nano generator and the sensors here. So you see, trouble electricity is very popular in the fabric structure here. So this is the fiber-based ones. Raindrop. 2014, we demonstrated for the first one use raindrop for power generation. In recent years, many groups started raindrop, but we were the first one to demonstrate this one because raindrop have the charge on the surface and also charge exchange with the surface here. When drop hit the substrate, you can have a charge exchange, and then when the drop float off, you have a power generator. You can see this. This is the power generator here, and this is the lights here. Use this flashlight here. You put on from here, you see the light flash. Okay, so then turn this off. So you can see this one is raindrop as a power generator here. A lot of interest study recently here. You can use it as a model. Okay, this is the electrostatic model. You can use the TNG to drive electrostatic model because TNG have a high output voltage, and this is very unique for electrostatic application. You can see this is sliding on the right hand side, and this model runs at 1300 round per minute for medical purposes for some of the solar-powered model sensors here. Okay, many people work on storage, energy storage, but for our system it's different because the energy from the environment is variable. It's faster or slower, frequency variable, amplitude variable. Through our TNG, we can make into power, but it's pulse power. So we have through a power management, then through a storage unit for regulated application here. So we call self-charging power unit. It's a unit that can harvest energy, manage energy, and storage energy, and then you can utilize the energy. So it's different from battery. Battery is just a storage, a simple storage without the previous two components. The three components are all equally important for this device application here. So this is the reason we make the power management, because the TNG has a high output voltage, lower output current. Our purpose is to lower the voltage and raise the current. So you can see this one. You can see this. This is the power. This is the TNG, and this is the power regulation unit, and this is the output. You can be a effective user. We already reached 85% of this effective power management here. Okay, so this is the utilized for power management system for self-charging power unit. In the environment, you have a lot of sensors. You have wind sensors. You have